going to be recording all of my lectures as well. So I know it's 8 o'clock a.m. Yeah, right now, like the first day, you'll probably like have some determination. Like I'm gonna show up to class every single day. Maybe that will change in November. All the recordings, like all the lecture recordings will be posted on Canvas. So if you miss a lecture, you can watch it later. And some people learn better watching videos, so you can watch at your own speed and look through other like explanations and stuff like that. So I feel like it's a good idea to record the lectures for your ability to learn better, pretty much. So I'm gonna, and this is the boring part. I'm gonna briefly go through the syllabus. You can find the syllabus online. I didn't want to waste paper printing it off, but I did print out like the notes. So, and I'll be doing this. I'll print off the notes every single week. Yeah, so what do I really want to say from the syllabus? Yeah, so this is kind of what I was saying earlier. Corpse description. This is really like your foundations in mathematics and computer science. There's like another class called Principles of Mathematics, which is going into mathematical logic and proofs. This is pretty much the same class, except there's more of a focus on computer science. And so we're going to be looking at sets, sequences, strings, symbolic logic, proofs, mathematical induction, number theory, amongst other things. Like eventually we'll be going into graph theory and finite state machines. And really this is, I mean, we're not going to be doing programming. We might look at like algorithms or examples demonstrated in programming, but this is really the foundations of programming. Like you can do Python, C++, whatever language. There's going to be a different syntax going from language to language, but the foundation is going to be the same for all of them. So if you have an understanding of discrete mathematics, it should give you a better understanding of programming in generality, regardless of like what programming language you're going to be utilizing in the future. That's kind of the, I guess, the existential justification for this class, I guess. Like this is kind of like the thinking people were doing before, like when setting the groundwork for programming in the first place. Everyone's in this, so I don't really think I need the prerequisites. This is what the grading scheme is going to look like. So there's going to be like a 5% attendance participation. I'm not really the big stickler on attendance, to be completely honest. This is pretty much free credit, is what I would say. The only day you're really going to have to show up, and it hurts me to do this, but I feel like I need to. There's going to be quiz days. So every Friday, except, I mean, there's not going to be a quiz this Friday, but in general, there's going to be quizzes on Friday. I'm going to try and make it so the quizzes are pretty easy. Like they're largely just going to be definitions and really basic examples. Like I don't like making like really punishing quizzes or quizzes that are unpredictable. And sometimes I'll tell you exactly what's going to be on the quiz before you actually have the quiz, maybe like the Thursday before or something. The part that pains me is it's 8 o'clock a.m. and I know some people aren't morning people, but I'm not really a morning person either, and I'm here, so it is possible. Well, actually, I don't know. We'll see how November goes. But yeah, there'll be quizzes. I'll try and make them pretty easy and predictable. There's going to be homework in this class as well. Homework is your main way of learning material in the class. I mean, you can listen to me lecture and I'll have the lecture notes, but if you're just like copying down what I'm writing during lecture, you're not really going to be learning anything, right? Like you'll have a vague idea, but it isn't until you sit down and actually like apply yourself and think through the problems that you're actually going to like learn the material. That's just how math goes in general, and probably like any STEM discipline. You have to sit down and work on it yourself. Like you can't really get better at sports by watching sports, right? You have to actually like practice. Homework is that practice. I'll talk about, I guess, like AI and homework later on. And then this is the part that's not fun. You have exams. So there's going to be 3 exams. There's going to be 2 midterms and a final. The final exam is going to be worth as much as any midterm. Like they're all just going to be worth 20%. I mean, I don't really have that much to say about the exams. Well, there will be before every exam, there is going to be a lecture dedicated to reviewing for the exams. I always do exam reviews as well. I try and make the exams pretty predictable. I would say like the average scores on my exams are usually like a B or like a B minus. So as long as you like apply yourself and you keep up with the notes and you know how to do like the homework problems or the quiz problems, the exams really shouldn't be that bad, to be completely honest. I know like I'm the professor saying like the exams aren't that bad. But at least like amongst my other classes, like the exams haven't really been an issue for students. And then the final, this is like a final in name only. It's pretty much just another midterm. I'm not sure if I'm going to make it cumulative or not. Ask me in November. I'm not thinking about it. we'll see how the class goes pretty much. And this is the grade cutoffs. This isn't even really worth mentioning. I mean, this is like the typical grade cutoffs. I'll adjust depending on how the class is actually doing. Like if everyone, I don't anticipate this, like if everyone is between like a 77 and a 73 or below, I'm probably going to make it so this is like an A or something. But I haven't ever had to grade my or curve my class. Like usually this is what it's going to end up looking like. Usually there's plenty of A's at the end of the class, so it isn't really that much to worry about. And then, I mean, you know what quizzes are. So quizzes will be given throughout the semester. They'll usually be in class. If you miss a quiz day, I would like it if you notified me before the quiz actually took place. And then you can take it in my office next week or something along those lines. Whenever it's like convenient for you, as long as it's not too far in the future. I don't want it to be like 3 weeks after or anything like that. But yeah, just let me know if you're going to miss a quiz. Just reach out to me beforehand. Again, the first quiz of the semester is going to be Friday of next week. It'll just be reviewing what we're doing today and then what we're doing on Monday as well. Okay, homework assignments. I haven't made the first homework assignment yet. The first homework assignment is going to be. Oh, I thought this would pull up a calendar. Isn't that what it's supposed to be? Who cares? Okay, it'll be. It's not Tuesday of next week, but the Tuesday of the week after that. So it's in 13 days. I think it's September 2nd will be the first homework assignment due date. So there's not homework due next week, but the week after that. And there's no class on Monday. So not Tuesday, on Wednesday. You don't have class on Tuesday. So it's going to be due on Wednesday, 2 weeks from today, not 13 days. Yeah, so the first homework assignment will be due 2 weeks from now. Homework is your main way of learning the class material, as I said before. I'm not really going to put restrictions on what you can do with respect to the homework, which I know sounds crazy, but it's just the world we're living in, I suppose. And that it's like, what am I going to say? Like, AI is everywhere in the internet now, right? Like, if you Google anything, there's going to be like an AI overview that kind of like tells you how to do things. So I'm not going to be like looking over your shoulder and being like, oh, they use like an AI on this or whatever. Like, it's kind of inevitable. And the important thing is, like, as long as you're understanding like what's being told to you, and like learning, that's the important part. The worst thing to do with the homework is just look up the answers and then write them down without learning anything. Because again, you have to know this stuff for the exams. If you don't know these things for the exams, like you're not going to do well in the class, and you're not going to have access to an AI on the exams because they're going to be in class. So you actually have to learn the material. But the homeworks, just do them as you want to, pretty much. I kind of view like the homework and the attendance, like hopefully these are pretty much just going to be free points for you. The quizzes, I'm hoping, are free points for you, but I mean, you have busy lives. Some quizzes aren't going to go well, probably. I might drop like the lowest quiz or something like that in the future, but I'm getting ahead of myself a little bit. What else do I have to say about the homework? So in terms of lateness with homework, there'll be a 5% flat penalty for each day that it's overdue. So if it's due on Wednesday and you didn't turn it in and you turn it in on Thursday instead, you'll get a 95% as your highest score instead of 100%. And then so on and so forth, right? So Friday would be a 90%, Monday would be an 85%, Tuesday would be an 80%. So there's some flexibility there. If there's like an emergency and you couldn't get the homework done, just email me and maybe I'll make an exception as well. Exams, the exams are going to be in class. They're going to be 50 minutes, barring the final exam, which is going to be an hour and 50 minutes. I have this classroom, like I teach in this classroom from from 8 to 11 o'clock. So if you don't finish the exam in time, you can probably just like sit in here, I would imagine, and just like work to the side while my other class works, I suppose. Like sometimes, I mean, some people take longer to do exams than others, so that's an option. Again, I'm getting ahead of myself. I don't even know if that would be a problem. But anyways, yeah. So the first exam is going to be October 3rd. It's like a month and a half from now. So it's in the far distant future. You don't have to worry about it yet. But this is the exam schedule if you need to know it. I'll have office hours. I usually have 3 to 5 office hours. Probably going to have 5 office hours because I have 3 classes this semester. I'll send out a poll later this week asking you what hours work best for you. So that way I have like the hours that work best for the most amount of people. I have 92 students this semester, so I'm probably not going to find hours that works for literally every single student, but I'm going to do my best, like the best I possibly can. Course objectives. This is a lot of text. I don't know if I need to go through this. This is something you can read on your own if you're interested in terms of what the larger overview of the class is going to be, as well as like the specific things we're going to be looking at. But I kind of talked about it earlier today, and it's not super important. You'll see what we're learning when we're learning it. If you want to see the overview, you can read that. Everything else, attendance, I kind of talked about attendance. I'm not really that strict with attendance. Again, I'm going to be recording all of the lectures. So if you prefer just like watching the lectures, you can do that instead. But it might be more convenient for you to show up to class and get that out of the way instead of watching a lecture at night or something like that. I mean, it's really up to your own discretion. Again, the only class you really need to show up for is going to be Fridays when you have the quizzes. You can't really take a quiz at home. So those are the classes where you'll have to show up. In general, I like it when people show up. Like in class, I might have some group activities that you need to work with, and that's going to be better if we have more people that are going to be in attendance. And plus, I don't want to wake up at 8, an empty classroom. So as long as like a couple of people show up, I'm fine. But yeah, like attendance, I'm not going to be like a huge stickler on it. I mean, again, it's 8:00 a.m. It's the earliest class I've ever had to teach. I can make changes to the syllabus. I already talked about technology and AI. So I guess when you're working on the homework assignments, as long as you're like learning and not just mindlessly copying things down, it'll suit you well, I think. Probably the best way of doing the homework is just thinking about it on your own, like the problems on your own, like giving it a genuine effort. And if you get stuck somewhere, like I don't really mind if you like look for help online, right? As long as you're learning things, it's better you learn things than get stuck and like give up, right? And never try. And then everything else, this is stuff you can read on your own. Yeah, so this is what the schedule of the semester is going to be looking like. Right. So, I mean, you probably don't care about this, but this is what I'm going to be following. So this is like the first day of class. We'll do a little bit of propositional logic today as well. I feel like I don't need to read through this. So yeah, this is what we're going to be looking at. We're doing. Okay. Any questions about the syllabus so far? Any questions about the class? Actually, I should probably keep the syllabus open for now. Any questions about the syllabus or any aspect of the class so far, or anything that I've said? Okay. I mean, yeah, I feel like it should be pretty self-explanatory.
This is the section 1.1 stuff, right?
Yeah, that's what it says. I'm debating whether or not I want you guys to do like an introduction to yourselves or not. You gave me the idea. People are shaking their heads. So I guess it's a no. See, that's how malleable. Okay.
What was the question?
Don't worry. I was asking if we should do like an introduction. But I'll learn who you are as a instead of kind of like this course introduction. So I'll be doing this each week. Like I print out the notes that I'm going to be following throughout the semester.
For us to use?
I do, yeah. Like you could, I would. This is what I'm going to be going over on my tablet. So there's like fill in the blanks and other things. So this is going to be your main resource when it comes to like, understanding what you need to be focusing on while exercising in this class.
I believe I brought up pen and pencil. Although and I got another pen.
Did everyone get a copy of the notes? There's probably extra, but. All right, so this is what I'm going to be following today, like this packet, and then I'll post the solutions as the week ends. Like on Friday, I'll post the solutions to this so that way you have access to everything that we've done throughout the week. And again, you can find this on Canvas, right? I probably don't need to be doing this, but you can find it like if you go on Canvas, modules, lecture notes, this is exactly what I'm following. And this is exactly where I'll be posting the solutions on Monday or Friday of this week. So on Friday, it'll be this exact same thing, except whatever I wrote down over the week will be here as well. So you can see all the solutions. Yeah, so it's kind of like, it's not a very mathematical day, I suppose. We're looking at propositional logic. So it's really going to be English, like how do you negate statements? How do you combine statements with one another? But really, I mean, that's kind of the idea with discrete math. Like this is going to be kind of starting math. Oh, you can't see what I'm even under right now. This is what discrete math is going to be. You're going to be moving away from doing a bunch of calculations, and it's going to be more writing and more kind of like alphas, x's, variables, and stuff. Like it's going to be more words than numbers sometimes, and that's kind of illustrated by this section on propositional logic. So the rules of logic give precise meaning to mathematical statements. It's going to allow us to determine whether or not a statement is going to be true or false. It's going to go into like Boolean variables, Boolean expressions. Like if you're on Python or like any sort of programming language, it's really common to have conditional statements to determine whether or not like another line of code is going to run. Like you can have like if I is equal to 0, then you do this. That's an example of like that's like a conditional statement, but like it's making use of propositions. Right. So these rules of logic are going to be used to distinguish between valid and invalid mathematical arguments. A major goal of this class is going to be teaching the student, not the reader. How can you tell I copied and pasted this? How to understand and to construct correct mathematical arguments. And so like the first thing we're going to do is just like an introduction to logic. So this will be the first 2 weeks is really just an introduction to logic, introduction to proofs and stuff like that. So it's like, why do we need to understand mathematical reasoning and logic? It has numerous applications to computer science. Really, it's the foundation of computer science. So like applications is really underselling it, I would say. So these rules are used to design computer circuits, the construction of computer programs, verification of the correctness of programs, and in many other ways. Furthermore, software systems have been developed for constructing some, but all types of proofs automatic. And that's, I guess, more true now than ever with like AI being capable of constructing some rudimentary proofs. So this is the basic definition of a proposition. So a proposition is a sentence that declares a fact that is either true or false, but not both. So it doesn't really seem like a very mathematical statement, but it's really the foundation of mathematical speak. And so just like a really basic first example, I'm going to ask you to determine which of the following are going to be propositions. And we'll just go one by one. If I were to ask you, what time is it? Is this an example of a proposition?
No, but it is not a statement, nor does it declare a fact. It asks a question that requests as a sentence to like a proposition in response.
Yeah, so this is a question, right? Like we're not asserting any sort of like true or false statement to it. Like we're just asking a question, right? So this is not a fact. Okay, the second statement, Toronto is the capital of Canada. Is this proposition or no?
Proposition.
Yeah, right. Well, yeah, it is a proposition in the fact that we're stating something, right? Is this true or false? It is false. Frankly, I don't know what's the what's the cap? Is it Ottawa? You learn new things every day.
Yeah, no, but
I mean, it's something I should know. It's Ottawa. Okay, this one's a little bit trickier. And me saying that kind of gives it away, I guess. Is this a proposition? So we have x plus 1 is equal to 2. Is this a proposition?
no, because we're not informed as to what value is assigned to x. Therefore, it could be out, which makes it not a proposition.
Yeah, so this is not going to be a proposition. The reason it's not a proposition is, we don't know anything about x, right? Like this could be neither true or false. Like in order to determine if it's a proposition, we need to have an assigned value for x. So if x were equal to 1, this would be a proposition that's true. If x were any other value, it would still be a proposition, but it would be a false proposition. But because we don't know anything about x, this is neither a true or false statement.
Because it's both.
And then the last one, I feel like you guys have the hang of it, but this last statement, is it a proposition?
Yes.
Yeah, it's yes.
False.
Yeah, so despite the fact that it ends up being false, it's still a proposition. Whether or not it's true or false, it's still a proposition. Oh, and it's definitely false. Okay, so that's just like a basic introduction to being able to recognize a proposition. In the future, I'm really what the goal of this lecture is going to be is exposing you to propositions and then being able to combine propositions together using ands, ors, looking at negations, looking at conditionals, biconditionals, etc., which are really common in every single programming language you'll ever be exposed to. And so we're going to be thinking sometimes abstractly with respect to the propositions that we have. So we introduce propositional variables. And so these are going to be variables that represent propositions. Just like the letter X is sometimes used in algebra to represent a number or a term, we can do the exact same thing with a proposition. So conventionally, propositional values can be letters like P, Q, R, and S. Really, P stands for proposition, and then you just go in alphabetical order from there. That's the logic to this. And then there's going to be, well, generally, if we have a proposition, we know it's either going to be true or it's going to be false. So we can assign a truth value to a proposition. If a truth value is true, we're going to denote it by T. And if it's false, we're going to denote it by F for false. And so given a proposition, this is what I was getting at earlier, one can construct new propositions via what's called a logical operator. And so this first section is just going to be me going through the big logical operators. So the major operators that we're going to learn and they're going to be used throughout the entirety of the semester are going to be the negation, conjunction, disjunction, and then the exclusive or operators. And then eventually we'll be looking at like conditionals and biconditionals as well. And so in layman's terms, like, I mean, in going through this book, this is the first time I've seen like conjunction, disjunction. Negation is really, if you've done programming before, it's usually like this not operator. Sometimes it's denoted by like a exclamation point or something along those lines. The conjunction corresponds to and, which is sometimes written with like this ampersand. Depending on your language, I feel like I shouldn't be writing down like what they're sometimes referred to. Disjunction corresponds to or, which is sometimes expressed as like a vertical line, at least like in R and Python. And then there's the exclusive or, which is kind of like the or, but it's more pretentious. It's like it doesn't allow like two truths. If you have two truths, then it like outputs a false. And so I couldn't find a more engaging way of doing this. I'm sure there is a more engaging way, but like really this page, like the rest of this page and the next page is just me going one by one, defining what the logical operator is going to be and then going through an example.
Oh, should I put my name on this?
No, you're not turning this in. Like this is for you to keep. I mean, I have my own. I don't need anyone else's. I have my own. Yeah, so we're just gonna go one by one. I told you it was gonna be a boring day, but it'll get more exciting as time goes on. Like eventually we'll be going on the truth tables, and it's like, well, look how crazy the statements get. So we have to understand the basics in order to eventually understand like the truth of statements like this, right? So I mean, bear with me. It's gonna get a little bit more exciting. I have a question.
The response is to the example here.
So well, don't spoil it.
Does not have at least 32 gigabytes of memory.
Maybe it will be. We'll find out. Okay, so we're gonna start with negation. We have the definition. I mean, it's kind of intuitive. So we're going to let P be a proposition. This is our variable. And so we're going to be thinking about the negation of P, which is going to be denoted by the following. Right, so it's like this line, and then you hook down a little bit, and then P, as you can see. And so what we're doing with our statement is we're negating it. So this means like if we have a statement P, we're pretty much putting the words, it is not.
The negation symbol in the final example.
What? We'll get there. So it's pretty much taking your statement P and then saying like it is not the case that P. And you can be a little more creative in terms of how you write like it is not the case that. And so the truth value of the negation P is the opposite of the truth value of P. And so we'll get to this eventually, but if you go on the top of page 3, I introduce these truth tables, which is a convenient way of understanding what these operations do, right? So if you look at this first truth table, what our input is our initial proposition P. And then P can have 2 potential values. It can either be true or it can be false. And so if you negate P, if P was true, it's now going to be false. And then if P is false, if we negate it, it's then going to become true, right? So it just means you're flipping it from true to false or false to true, right? And it'll get a little bit more exciting once we introduce like these other operations that require 2 inputs or propositional inputs. But for now, we're looking at negation. So it's really just taking something that's true, making it false, or vice versa. And so this first example, it wants us to find the negation of the following proposition. So the statement is Vandana's smartphone. Yeah, but I mean, we should be doing things in sequence because we're a class and not an individual, right? So we have Vandana's smartphone has at least 32 gigabytes of memory. So this is our statement P, our proposition P. It's kind of maybe this is a little pedantic, but this is our statement P, our proposition. It's stating that we have, or her smartphone has greater than or equal to 32 gigabytes of memory. So if I wanted to negate this proposition, what should I be writing instead? Like, how do I write the opposite? Yeah, over there. Yeah, sure. I mean, you can just throw in the word not, right? Or there's like other ways. There's a lot of different ways of writing this, but you can write out Vandana's phone. And you can say like has less than 32 gigabytes of memory. Right. Or you can say like Vandana's smartphone does not have at least, like there's a lot of different ways of writing it, right? But this is one way of saying it. So we were saying greater than or equal to, and now we're saying less than. So like less than is kind of like the opposite of greater than or equal to. Any questions about this example?
It deals with it all x with it deals with all cases, right?
Yeah, exactly. So if it's not greater than or equal to, like any other case is handled by like the less than. Yeah, and so this is kind of what we're going to be doing for like the other examples as well. So these other one, oh my god, conjugation. There should be shouldn't be conjugate. There are going to be typos. I'm going to warn you throughout the semester. There will be typos. There's probably already been some that have been right. Yeah, so this should be conjunct, which it says here, but conjugation is well, it depends on what you're talking about. Anyways, yeah, so this one involves, this is a little bit different from what we were just doing. The negation requires only one proposition. When we're doing a conjunction, we need 2 propositions. So we're going to have 2 propositions, P and Q. The conjunction of P and Q is going to be denoted in the following way. So it's like this P, and then we have like this wedge Q. And so it's going to be the following proposition. So we get a new proposition from this. So if you do a conjunction of P and Q, you get this proposition P and Q. This is usually how it's going to be denoted. And so the truth value of P conjoined with Q, or P and Q, is this is going to be true when both P and Q are true, and it's going to be false otherwise. Right. So if we look at this truth table on page 3, this goes through the possibilities when it comes to conjunction between the 2 propositions P and Q. Conjunction. Yeah. So this is like if P and Q are both true, then the output is going to be true. All the other possible outputs are going to be false, right? So as long as one of these values is false, the output is going to be false, right? So we need P and Q to be true in order for this to be true, right? We don't have P is true and Q is true here, so it's going to be false, etc., right? So this is going to be very important. Like these, again, these are going to be very important throughout the semester. You're going to have to know this stuff, like the back of your hand, I suppose. Yeah, so we'll go through kind of another basic example. I mean, this isn't the most exciting example in the entire world, but it's really looking at what we were just doing before, except now we'll have two propositions instead of one. So for this example, we want to find the conjunction of the propositions P and Q, where P is the proposition that Rebecca's PC has more than 16 gigabytes of free hard disk space. And then Q is the proposition that the processor in Rebecca's PC runs faster than 1 gigahertz. Right, so, I mean, I kind of tell you already, but this is P here. And then in blue, this is our Q. And we want to combine these two statements together via this conjunction, or really like the and. And it's really, I mean, it's exactly as it's written here, right? Like we have a statement P and a statement Q, and we want to and them together. So, I mean, if we wanted to conjoin these two things together, like what would it look like? Does anyone know how this would read? Yeah, go ahead.
Rebecca's PC has more than 16 gigabyte free hard disk space, and the processor in Rebecca's PC runs faster than
Yeah, exactly. I mean, all we're doing is just taking these propositions and then putting an and between them, right? Let me write this down and then I'll take your question. Yeah, this is why this lecture is not the most exciting, because it's mostly just me like rewriting exactly what's been written already, except putting like one word between them. So it's more. But I mean,
was raising my hand part was an example response that I thought of.
Hey, go ahead.
Rebecca's PC has more than 16 free hard disk space, 50 gigabytes free hard disk space, and a processor that runs faster than 1 gigahertz.
I mean, yeah, that works just fine. That works well. Yeah, it's a little bit tedious writing this out, I understand. But I mean, we'll be getting to more exciting stuff after this. And then I can copy and paste this one on the next one, except change one word. Okay, so that's an example of a conjunction, right? This is kind of like a really basic example. Any questions about this before we move on, or anything we've done so far? Okay, disjunction, it's
My suggestion was to be a bit more efficient as we tries to avoid the needed aid for the repetition of PC.
yeah, it's fine. It does make things a little bit more efficient. Yeah, the next one is going to be the disjunction. So it's kind of the same setup, right? Except we're going to be more lenient about what's going to be true and what's false. So again, we're going to let P and Q be propositions. The disjunction of P and Q is going to be denoted in the following way. So it's kind of like P, and then you have like this weird V shape, and then Q. So it's really just taking this wedge we had before and flipping it upside down. And there are kind of like it kind of does have an opposite effect in a sense to like the conjunctions we were doing before. And so instead of doing P and Q, this conjunction or disjunction is going to be P or Q. So this is going to be or instead of and. And so the disjunction P or Q is false when both P and Q are false, and it's going to be true otherwise. So it's kind of flipping this final statement we had when we were looking at conjunctions, right? Instead of having true, we have false here. And instead of having true, we have false here. Like we're flipping, it's pretty much the same idea, except we're flipping these terms that I've underlined, right? And this isn't really like the best way of, maybe it is the best way of thinking about it. I don't know. But it's one way of thinking about it at the very least. And so as before, a really good way of understanding what the disjunction or the or is doing is you can look at the truth table. So this is going to be table 3. So if you look at the truth table, this is the truth table for disjunction, and it's going to be different from what we were looking at with conjunction, and that we're going to be more lenient in terms of what we allow to be true.
False truths and the truths and how many truths and faults there are.
Yeah, so as long as one of the variables or one of the propositions is true, the output is going to be true as well. So if you look at the first row, this is saying like we have P is true and Q is true. So that means P or Q is true. So it's going to output true. The second row, we're assuming P is true and Q is false. So because P is true, that means P or Q is going to be true. Like this is saying like P is true or Q is true. As long as either one of these is true, then you're going to output a true. Similarly or analogously, we have like Q is true, so this will be true, and then both of them are false, so that means it's going to be false. So neither P or Q is true, so we output a false. Okay, and so kind of going back to the other example that we were looking at. So the example is like, what is the disjunction of the propositions P and Q, where P and Q are the same propositions as the previous example. I like participation, but I'm just going to tell you, like all we're really doing is just changing the word and to or. So it's not the most interesting thing of all time. So you don't have this luxury if you're writing this with your pen and paper, but I'm just going to copy and paste and then change the word and to or. So like we're saying, Rebecca's PC has more than 16 gigabytes of free hard disk space, or the processor in Rebecca's PC runs faster than 1 gigahertz. So they can both be true, or one can be true, the other can be false, or vice versa, right? All I'm doing is just changing and to or. And that's generally like, I mean, conjunction and disjunction, this is going to be your bread and butter. It's going to show up all the time. And if you're programming, you're always going to be doing like ands and ors.
Or and 16 gig of
Yeah, and so this disjunction is also called the inclusive or. And the next thing we're looking at is known as the exclusive or. So this exclusive or is similar to the or that we were just looking at, except it's going to be more specific about like only one can be true, right? Only one of the statements can be true. They both can't be true. Otherwise, they'll output false.
that.
So this is the definition of the exclusive or. So if we have P and Q are propositions, the exclusive or of P and Q is going to be denoted by the following. So it's like this P and then it's a plus sign with a circle. I think it's commonly referred to as like XOR as well. Like maybe you've seen
And
this.
that was mentioned on the first page.
Yeah, that is true. And so this is going to be the statement or the proposition that is true when exactly one of P and Q is true or false, or true and false. I didn't read that correctly. It's exactly true, or true exactly when one of P and Q is false, and it's going to be false otherwise. So again, the best way of understanding it, at least for me, is looking at the truth table. And so you can just compare this truth table with this truth table. It's going to be the exact same. The only difference is going to be with the exclusive or. If we have P and Q are both true, then it's going to output false. Whereas this was true before. And then these other ones, we have P is true, Q is false, so it's going to output true. P is false, Q is true, so it's going to output true. And if they're both false, it's going to output false. Right. So the only thing that changes between the inclusive or and the exclusive or is when both truth values are going to be true. Okay, so we can look at, maybe this will probably be the last example I do today before ending class. So for this example,
8:47 according to my Fitbit, or 8:45 according to my computer.
I'm more of an 8:47 guy. If it's 8:47, I feel like class needs to wrap up. So this is this statement. We have let Q or let P and Q be the propositions that state a student can have a salad with dinner. The other statement is a student can have soup with dinner. And so what I'm asking is, what is the exclusive or of P and Q? Does anyone see how to combine these two propositions with the exclusive or? You've answered before. Yeah, go ahead.
A student can have either a soup or salad with dinner, but not both.
Yeah, exactly.
That's
Exactly like
pretty
the,
much
but not both is exactly, yeah, it's like the important part. It's like one way of writing this is a student can have salad or soup with dinner, but not both. Right, so with the disjunction, it would have been fine, like you don't need, if we were doing the inclusive or, you don't need the but not both. Right, they can have salad or soup with dinner, but with the exclusive or, you have to make sure you include the but not. Any questions about anything we've done today before we end class?
Is there a pencil sharpener?
I don't think so. Yeah, and so next week, or I guess on Friday, we'll be going into conditional statements. We'll be continuing section 1.1.
And then finish it up on Monday.
Yeah, we'll probably start section 1.2 on Monday.